topic, the consequences of the vanishing Arctic ice. And today's guest is Dr. Peter Wadhams, expeditionary Arctic researcher. He's also Emeritus Professor of Ocean Physics from Cambridge University. Now, Peter has written a book recently, and in this he details his history in the Arctic, his experience there, his predictions, his concerns. Peter has been going under the Arctic ice pack for 40 years on nuclear submarines, pointing the sonar up to map the thickness of the ice, because from satellites you just see the extent, how much it's covering, how much area. Now, this is one of the maps that come out of this data, but it looks like a terrestrial map because it's upside down. That's essentially how it should be viewed. We're looking at the thickness or thinness of the Arctic ice. Here's another one. You're looking at a mountain range in the Sierras. No, you're looking at an undersea range of thick ice, multi-year ice. The multi-year ice is vanishing.
What we've been doing over the last 40 years is measuring the ice thickness in the Arctic using submarines. And that really was what gave the clue to how rapidly the ice is retreating, because up until then, or up until we started doing this work, it was only possible to see the ice retreating from satellite data. Satellites show you the extent of the ice, they don't show you the thickness. But from going out in submarines over successive years, over 4 decades, we from Britain and our American colleagues were able to find that the sea ice was thinning and is now about 40 to 50% thinner in summer, in fact in all seasons of the year, from what it was like in the 70s and 80s. So we now have, in the summer, the volume of ice is only about a quarter of what it was in the 70s and the 80s. That is to say, the area is about half and the thickness is about half, and so the volume is only a quarter. Yes, this shows how the volume of the ice at the time of the minimum, which is September, has been declining in such a rapid way that it's going to reach zero very shortly. And that will mean that we will have a short, at least, ice-free period in the Arctic, although that will grow longer as time goes on. And already in the winter, we see that the ice is now unsafe for anybody to work on. We used to do our research in the Arctic in winter by landing on the ice, setting up camps which were maintained by aircraft, but now we find that there isn't enough ice that's free of cracks. This is a view of part of the Arctic pack ice in March, when it ought to be solid, and instead you've got this network of leads all over it. So you can't work now from ice camps, so you have to work from ships. You have to freeze a ship into the ice, such as in this case was done 3 or 4 years ago, or using satellite-tracked buoys, and that's what we're doing mostly now, installing instrumentation in the ice and on the ice, which transmits data back by satellite and doesn't require human beings to be there. And a lot of that work is at the moment is being done in a European program called IceArc. So this is what the ice is now like in summer. Very, very weak, thin. You can see it's on the verge of disappearing altogether. There's a number of different effects that this has, that the retreat of sea ice isn't just a phenomenon that you heat, the climate warms, the sea ice melts, that's obvious, but that melt has further impacts, it has further feedback effects which make the overall global effect of sea ice retreat much worse than you would expect purely from the effect of the warming itself. In fact, calculations show that you're getting overall heating effect on the planet, which is at least 50% higher than the direct heating effect from the addition of greenhouse gas. We're getting a feedback which is speeding up global warming.
So we're getting bigger feedback from the Arctic than from the CO2 in the atmosphere? Is that what you're saying?
Yes, we're getting, we're 50% extra. That is.
50%. Not as large an amount, but it's an additional 50%
Additional amount.
we didn't need.
So one of the effects, this is not the main one, but it's another effect that we see going on, is that in the Greenland Sea, which is an area which used to be ice-covered in winter and now isn't, we used to get these phenomena, which we discovered in some of our field work, which is of called chimneys, which is where because of ice forming on the surface, this rejects salt and you get sinking regions where,
like a vortex.
It's like somebody opened a plug hole in the bottom of the ocean, and you've got a rotating cylinder of water going down from the surface almost to the ocean bed. This blue column is cold water sinking down from the surface down to 2,500 meters, and after it sinks, it spreads out southwards into the Atlantic. And it forms part of an overall circulation called the global conveyor belt, the thermohaline circulation, and that helps to keep Europe warmer than it would otherwise be, because the Gulf Stream forms part of that circulation, and we're getting therefore a warmer climate in Europe than we ought to have. So this is the only effect of sea ice retreat that actually is cooling, is the fact that the circulation is slowing down because the ice is not forming in the Greenland Sea anymore. We're not getting these chimneys forming anymore, and as a result it's slowing down, and that warming is less, so that Britain and Western Europe are projected on that map to have only 2 degrees of warming this century, while the surprise-free prediction for the rest of Europe is about 4 degrees. So we see Britain and Iceland and the Atlantic coastline getting less warming. But of course, the heating is still there, is going into the ocean, and what that means is that there's less heat being transported north out of the tropical Atlantic, out of the Gulf of Mexico, to reach Europe, and that means that the tropical Gulf of Mexico is warming up faster, which means we're getting more and more intensive hurricanes there and less heating here.
Unusual to have a guest here and include a video clip, but it was because I've done this twice because of things that Peter said so well in videos that I wanted to start out the topic.
Yes, in Arctic research at the moment, there's a huge disconnect between observations and models, and I'm trying to understand how that's arisen. And one of the possible reasons is, of course, that observational work is very expensive.
Now, I want to use that statement to kick something off. There's a disconnect between climate models and real-world observations. So what we're saying is that the IPCC process is a prediction based on computer models. Can you continue that?
Faults with the IPCC process are largely that it's based on past changes, because work has to be already published for a couple of years before it appears in IPCC assessment, and the work itself, if it's observational work, takes a long time to do if you're making measurements in the Arctic. So therefore, IPCC analyses tend to be somewhat out of date. But also this problem with modelling, not all models are bad. Some of them, there's a few that give very good results that are in tune with data. But on the whole, there's a tendency in modelling to believe if you see a model, you believe the results of the model rather than after comparing it with data believe in the data or have to modify the model. And Richard Feynman, who's a very famous theoretical physicist, said you can have the most beautiful model in the world, but if it doesn't fit the data, then it's wrong. And that tends not to be taken to heart by modelers in a way, because there are many more modelers than observational scientists these days.
And also, you have careers based upon those models. To acknowledge that your model might be flawed might ruin your career or decrease your grants.
Yes, there's that, or there's all of that as well. But the problem is really to include all the processes that are going on in the Arctic in a model. And we find, for instance, that the current work we're doing in the Arctic involves, one of the things we're looking at are waves, that as the sea ice retreats in summer, you get a lot more wave action, and that acts on the ice and makes it retreat even faster. That's a process which we observe and measure, but it's not included in models. So you've got a lot of these small-scale processes that go on where a modeler working entirely in the office can't really see that these things are happening. So the disconnect, it's a matter of mutual learning, I think, that perhaps people should go out to the Arctic more and actually observe what's going on.
But I know there have been times when modelers have very unjustly been rude to you at scientific conferences because they have such a stake in their models being correct.
Well, that's certainly happened, yes. I think,
Peter's somewhat more modest than I would be. I would rant about that, but that's okay. So we're talking, in my estimate, about a flawed IPCC process because it relies on the models too heavily. It's much more expensive to do the research, and it's difficult to factor in things that are happening that you don't see because you're not going there. Now, I'd like to shift to something many people call the Arctic methane emergency, and I'm just going to let you take that away, Peter, and you can step through the slides.
Yeah. Okay. Well, this is one of the impacts of Arctic sea ice retreat that could be most serious. I mean, the ones that one I've already mentioned, the change in the albedo of the planet, the increased warming effect because the warmer. The melting is causing snowline retreat as well. That those are all, and the fact that the warmer air is causing sea level to rise more rapidly through causing a melting of the Greenland ice sheet. But the one that could be a real game changer and very nasty is the problem of offshore methane release. If you look at this map of the Arctic Ocean, you can see that the center of the Arctic Ocean is very deep water. It's about 4,000 meters deep, but there's a very wide fringe of shelves around the edge of the Arctic where the water depth is only 50 to 100 meters. So it's really like one of those swimming pools where you can, if you're a child, you can paddle around the edges and then you can dive into the deep bit. But in that shallow water, underneath it, there's a huge reservoir of methane. That's in the form of methane hydrates, which looks like ice but isn't. It's methane gas contained within a cage of ice, and the offshore methane was sitting there because it was capped by permafrost. That permafrost was left over from the last ice age, and it continued in place because with the sea ice covering the ocean even in summer, the water temperature never rose above zero, and so the permafrost never melted. Now the sea ice is retreating, we find that the water warms up to 5 degrees or more during the summer, and as a result, this cap of permafrost is melting and releasing methane from the sediments up to the surface. So we see every summer we go up there are more and more big plumes of methane coming up from the seabed being released into the atmosphere.
So the methane in the atmosphere, the total amount of methane in the atmosphere, in the current atmosphere, it's about 5 gigatons. The amount of carbon preserved in form of methane in this southern Arctic shelf is approximately from hundreds to thousands of gigatons. And of course, it's only 1% of that amount is required to double the atmospheric burden of methane. But to destabilize 1% of this carbon pool, I think it's not much effort needed, considering that the state of permafrost and the amount of methane currently involved.
This is work done by a Russian group. This is an underwater vehicle photograph going through a methane plume, showing the methane bubbles rising. Then these are the bubbles reaching the surface, and they're flattened against some very thin ice, which is transparent, so you can't see it, but you see the flattening of the methane bubbles. And then this is from a ship, and it's a sideways-looking sonar, and it's giving you a reflection from each of these methane plumes. So we see a whole mass of methane plumes. This is in the East Siberian Sea in a water depth of only 70 meters. So at 70 meters, all the methane comes out into the atmosphere, whereas if the water depth were much greater, some of the methane would dissolve.
That's the most alarming part of that message. If this methane comes out, if there's a burst, and one of your colleagues, Dr. Shakova, is estimating that there's a 50 gigaton burst underway right now. It's a very, very difficult thing to quantify because we don't know, we just don't know. But we should be planning, we should be thinking about that, because that 50 gigatons of methane would more than double the carbon equivalent content of the atmosphere from 400 to about 800 to 1,000 parts per million. I'm losing it. I want to shift to a little bit more speculative.
Do you think our children have a future?
Our children have a future only if we take action now. And my fear is that the current generation of world leaders, politicians, I won't call them statesmen because they're not, is too cowardly to take any action now, because any action would involve such a large disruption of our present way of life that they don't want to take it because they might not get re-elected. So there's a conspiracy of complacency throughout the world in which they still imagine that if we do a few minor things and a few minor adjustments and reduce our carbon dioxide emissions, then all will be well. But it won't, because we've already got too much carbon dioxide in the atmosphere. We're already going to have more than 2 degrees warming, even if we don't emit any more because of the already existing carbon dioxide in the atmosphere. So we've got to not only stop emitting it or reduce the emissions, but find ways to take it out of the atmosphere. And that's a technology that hasn't been developed. Would be a massive research program to develop, but we should be doing it. It's a bit like the Manhattan Project. We should be doing it from the point of view of our own survival, and that's the sort of thing that the present generation should be concentrating all our attention on. And if we can do that, then our children have got a future.
Now, Peter, I don't know if you want to amplify or back away from those comments.
This interview was given before the Paris Agreement, so I was pleasantly surprised by the progress that was made in the Paris Agreement. I thought at that time that there simply wasn't going to be any agreement that would slow anything down. In theory, the Paris Agreement does give that possibility, and hopefully if it's strengthened by successive meetings like this one, then things we won't be able, as I would still say, we're not going to keep to the 2 degrees because we're already there, and my feeling is we're going to have to go to direct air capture or geoengineering to be able to technically reduce carbon dioxide levels. We're not going to be able to do it by reducing our emissions because we've already got too much in the atmosphere. So in that sense, I'd agree with my previous remarks, but the feeling that politicians are not prepared to do anything has been, I guess, pleasantly changed by the Paris Agreement.
An agreement which may be severely undermined by the change in administration in the United States. I still feel that there's a compromise going on there because the governments are still too beholden to economic interests. They got to keep their economies growing. It's hard to do what we need to do if you're trying to also keep your GNP, your GDP growing exponentially. That's the conflict that I see in society. I want to thank you very much, Peter. I want to thank you all for coming. Again, here's my email address. We're going to be followed by another Climate Matters show where Peter and his wife, Maria Pia Casarini, who's with us in the audience, will come up and discuss the Arctic further. You're most welcome to stay. And thank you very much. Again, we've come to you from COP22, Conference of Parties in Marrakesh, Morocco. Thank you.